At the end, I just started going. Like, the kid was there buying everything all, I would just go.
Nice when they have a license.
It's like you took like a minute every.
All right, kids, thank you for your patience. I'm trying to figure out, they changed screencastify on me, so I need the old man had to try to figure something out real quick. We had a worksheet on Friday that dealt with solving equations that work with the rational equations and also radical equations. The front side were more the rationals, the back side were the radicals. Anything on the front side you would like me to go through? On the front, just on the front side first, just the rational equations. Once again, you're going to utilize your factoring, yeah. Number 4. Number 4, we have x over x minus 3 plus 3 over x plus 3 is equal to 6x. Now what I'm going to do is I have x squared minus 9, and I'm going to look myself forward in regards to this. I'm going to need to factor this down, so I'm going to factor this as a difference of perfect squares, x plus 3, x minus 3. Okay, so that's my difference of perfect squares. Now, what we need to do is find a common denominator that will eliminate all of our denominators. Once again, I have an x minus 3 factor here, or denominator, x plus 3 factor, denominator, and I have a combination of both of them. So that's going to give me my common denominator that I'll need to multiply through by. So I'm using my multiplication property of equality and being able to multiply through by this. Now don't try to do too many things at one time. As you multiply through, the x minus 3's cancel on the first one, leaving us with our x that's still on top times x plus 3. If I multiply this through the second one, my x plus 3's cancel. If I'm still up to the 3 and an x minus 3, and then on the right hand side, everything cancels out to give me 6x. Okay, slow yourself down as you go through the problems. Okay, don't try to do everything all at once and try to distribute your x through. You're going to lose mistakes, or you're going to have mistakes as you go through that. Now we can go ahead and distribute this out. So we have x squared plus 3x in the first one. We have another plus 3x minus 9 in the second one. And then we have, that's equal to our 6x. Combining the like terms, we have x squared plus 6x minus 9 is equal to 6x. We have a quadratic, so we can set it equal to 0, subtract your 6x. So we have x squared minus 9 is equal to the value of 0. Factoring this down, this will factor to x plus 3x minus 3 is equal to 0. So we have x is equal to 3 and also negative 3. Okay, once we solve this, we have a rational expression, which means we have variables in the denominator. We have to make sure our solutions do not make any of our original denominators equal to a value of 0. Well, if I put my 3 into the first one, I get 3 over 0, which is undefined. If I put negative 3 into the second one, I get 3 over 0, which is undefined. So both of these will give us undefined values, or undefined fractions, which means our solution is going to be an empty set. Okay, when we solve, once again, equations that have variables in the denominator, we need to make sure our solutions do not make the denominator equal to 0, and both of these do. Other questions? on the front side.
Yeah, number 6.
Number 6. We have 2x, x plus 3, minus x over x minus 1. And then we have equal to 14 over, and once again, I'm going to need to factor that down. So if I factor this down, I have an x plus 3 and an x minus 1. If I check my mental multiplication, I get a plus 3x, I get a minus 1x, so that gives me my plus 2x, which is what I want there. Need to find our common denominator. Common denominator, once again, need to take a factor and cancel out every one of these, which will give us x plus 3x minus 1. And once again, as you look at this last factoring here, you can probably look at the other denominators, and that may give you a hint what the factors will be for the second one, or for the one they have to factor out. Distributing through to each of our terms. X plus 3 is canceled, so we have 2x times x minus 1 in the first one. X minus 1 cancels into the second one, so we're left with minus x times x plus 3 for the second one, and everything cancels with the right hand side. Once again, slow yourself down because this is where mistakes occur, especially when we have a negative sign in there. Distributing, we have 2x squared minus 2x. Now we need to make sure we take the negative with the x term. So we have a negative x squared minus 3x with the second one. Okay, once again, common mistake here is we lose this negative that was attached to the subtraction there. And that's equal to 14. Combining our like terms, 2x squared minus x squared gives me x squared. We have a negative 2x and a negative 3x. It gives us negative 5x. And then we can bring our 14 over. And give us minus 14 is equal to 0. Factoring, x and x. Combination is 14 to give us, we have signs that are going to be different. We have 1 plus, 1 minus. We need to get negative 5, factors of 14, 7 and 2. So we have a negative 7 and a positive 2. Check our mental multiplication, we get a plus 2x and a minus 7x, gives us negative 5. If this came down to a positive 5, you just have to switch your signs around. So we get x equals negative 2 and 7. We can check here, here, to our factors. Negative 2 doesn't make anything equal to 0 on the bottom. 7 doesn't make anything 0 on the bottom. So we are good with our solutions. X equals 7 and negative 2. Okay, backside. Anything with the radicals? Anything with the radicals on the backside? You have to make sure and watch, bless you. Once again, on number 10, we have square root of 6x minus 11, or 6y minus 11. And that's equal to 2y minus 7. To get rid of our square root, we can square. Now when you square, once again, you must do entire sides. You can't do pieces parts with respect to your squares. So I just cannot square each one of my terms here. I need to do entire left and I need to do entire right. I need to do entire sides. So on the left-hand side, we have our 6y minus 11, but on the right-hand side, we have to FOIL out 2y minus 7 times 2y minus 7. So we have our 4y squared minus 14y minus 14y plus 49. Need to FOIL this out. And then you can solve the problem, solve the equation. So we have a 4y squared. We have minus 14 gives us negative 28. Minus 6 gives us negative 34. Y. Then we have 11 plus 49, which gives us 60. Now, if you want to sit there and try to find factors, that's fine. To make numbers smaller, I see you have a common denominator of 2 that you can factor out of both of these, all these. Might make your factorings a little bit easier. This is sort of a challenge of your factors. We have 2y and y. Then you have your combinations of 30 that you'd have to work through to get your values of 17 in here. Signs are the same, they're both negative. I'll try the obvious 6 and 5. And yeah, minus 5y and a minus 12y gives me negative 17, so that would be my factors. So y equals 5 2 and 6. As we talked about last week, you need to keep up with the material. You need to keep up with the material as we go through. Because this will bury you real quick if you don't keep up. And it's one of those things where if you did not complete your homework for today, my suggestion is you find some time to complete. Because it will be a snowball effect real quick on you if you don't try to catch up. So I know you had a long weekend. I know it's a weekend. Sometimes we don't quite adhere to our educational requirements, but you need to find time to be able to continue and keep up with the material that we're working with here. All right, today we're going to first start off with what is called interval notation. What we have done up till now is we've worked through solutions and just wrote out solutions that look like this right here. These were our solutions with respect to our inequalities. We're going to look at a different nomenclature in regards to how we can write this a little bit more standard, upper level method of rewriting our solutions rather than dealing with less than and greater than signs. And this is called an interval notation. If we take a look at a solution, x is less or greater than the value of 1, and also x is less than 5. If we look at our solution, x is greater than the value of 1. We have an open dot going to the right, and x is less than the value of 5. We have open dot going to the left. Okay, these are things that hopefully you remember. But what we need to go back and look at is the conjunction junction, what's your function term that we have in there, the word and. When you look at the word and, we have x is greater, we want the values of x that are greater than the value of 1 and also less than the value of 5. So we want the combination of both of those. So when we have the word and in there, we look at what is called the intersection. The intersections. When you have two sets of numbers and you're looking for the intersection, you're looking for the values common in both. You're looking for values that are common in both sets. Okay, not just one or the other, the values that are common in both sets. Well, if I take a look at the values that are common in both sets, what values are common in both sets here, Judah? Values between 1 and 5. Is 1 and 5 common in both sets? No, because 1's not in the first set, 5's not in the second set. So if I look at my solution here, I'd have an open dot on 1, open dot on 5, and a line in between. How else this can be written is x is greater than the value 1 and also x is less than the value 5. X is in between 1 and 5. I want the values of x between 1 and 5. Well, what we can call this is we can call this an open interval. Why do we call it an open interval? Because we have open dots. So it's called an open interval. So how we can write this, and it sort of looks like a coordinate plane idea with respect to an ordered pair. But we're looking at our variable x, and x is going to be a member of x is a member of, and we use our endpoints 1, 5. We use our endpoints where we start, where we end. Now what we put around this is when we have open dots, we use parentheses. So once again, it looks like an ordered pair, so it's important to get this x is a member of here, because if I just gave you this, you're going to be sitting there saying, well, that's just an ordered pair, 1 and 5. But if I take my hand away and I got x as a member of, now it's an interval from 1 to 5, and they're open dots on both ends. Now if we take a look at the second one, x is less than, greater than or equal to value 1, and also x is less than or equal to the value 5. Caden, what's going to switch it? What's going to change here with my graph?
I think it's circles.
It's good. Circles.
They're closed.
They're closed. Very good. Okay, they are solid dots here because now we want to include the values of 1 and 5. So if we take a look at our graph, we have 1 and we have 5, but now we have solid dots. Because we want to include, because we have equality there. This is called a closed interval. Well, what does this look like with respect to a closed interval? It looks very similar to what we just did up here. We have x as a member of, we still use our endpoints where we start, where we end, 1 and 5, but now, since we have a closed dot in here, we use what is called a bracket. So when you have open dots, you have parentheses. When you have closed dots, you have a bracket. But once again, we still need the x as a member of. Okay, we can have a half open or a half closed. Depends if you're optimist or a pessimist. Okay, I'll call it a half opened interval, where one of them is an open dot, the other one's going to be a solid dot. So we still have our 1 and 5 here, but we're open at 1 and we're closed at 5. Once again, you can call this half open, half closed, does not matter. So we have x is a member of, we still have 1 and 5 are endpoints. But since this is a closed dot, we have a bracket. Since this is an open dot, we have a parenthesis. We can have also something that's called an unbounded interval. An unbounded interval. X is less than the value of 2. So now we have just open dot of 2 going to the left. So when it's unbounded, that means we have no boundary value here. The 1 and 5, we had boundaries there. We had starting spots and we had ending spots. We had boundaries there. But we have a boundary at 2, but we don't have a boundary going to the left. So this is called an unbounded interval. So we still have x as a member of. We have a value of 2 there. This is going to be a parenthesis or bracket. Parenthesis because it's an open dot. So we're going to put a parenthesis here. But we're going towards negative infinity and beyond. So our left-hand value is going to be negative infinity. You can never have a definite stopping spot in infinity. So we put a parenthesis there. This is called an unbounded interval. Now, we're going to graph inequalities, and I know we know how to deal with inequalities. We should be able to deal with inequalities. Okay? What the key is going to be here is you learning how to write your solution as an interval notation. Now, one thing you have to watch out for with respect to solving inequalities. What's the one thing that's different when solving inequalities that we have to watch out for? There's one difference. Yep, when you divide by negative, you got to turn the sign around. Okay? When you divide by negative, so when you have that negative 2x is greater than the value of 10, and we divide this by negative 2, we have to turn that sign around. We have 10 and negative 5, we have x and negative 5, but this thing turns around. Okay, so go ahead and solve these two inequalities. Write a solution and get a graph down and write in interval notation your solution. And check your answers with somebody around you. Again, just watch your negatives here. You're solving an inequality just like you solve an equation. You want to isolate the variable. With our linears here, all your solutions should be unbounded. Okay, all your solutions should be unbounded. So you're just going to have an endpoint, and you're going to go either towards positive infinity or negative infinity, and that's where your graph helps yourself out a little bit. You're going to be out there with Buzz Lightyear. Watch your negatives with the second one. Tag your negative with the 3. So you don't lose that negative as you distribute it through. And I give you time to work in front of me. You need to work ahead of me, not copy down what I have up here. You need to work on you distributing out, you remembering your negative signs. Okay, I throw this up here for you to check, or you can check with the people around you. Yep. Solution should be once again, practice writing your interval notation here. Okay, what's your interval notation? And it might help you with respect to throwing a graph down there so you have some symbolization that's easier for you to deal with when you put it in interval notation. Brandon, what do you get for a solution in the first one? Just give me x is greater than or less than what value? You have 7x is greater than negative 19? What do you have to do to solve this? What would you have to do? Divide by 7. Divide by 7, so x is going to be what? Well, just leave it in a fraction form. Yeah, x is greater than negative 19 over 7. Okay, now, if you want to put it in decimal, that's fine. If you want to leave it like this, that's fine. This is going to be in between negative 3 and negative 2. Because if this is negative 14, that would be negative 2. This is negative 21, this would be negative 3. So I'm somewhere in between 2 and 3. And if you want to clickety-clack it through, you're going to get negative 2 and some change. So I'm going to be in between if I look at my number line, somewhere in between negative 2 and 3. Negative 3. You don't have to be exact with this. Okay? We have x is greater than negative 19/7. Do we have an open dot or closed dot here? Gavin? Open or closed?
Open.
Open. So we're going to have an open dot here. Which direction we're going to go with our line?
Positive.
Okay? We're going to go to the right because this will tell us the direction we're going. So now I can look at my solution. I have to go towards positive infinity. I have my boundary value at negative 19/7 to positive infinity and beyond because I'm going to the right. Okay, do I have a parenthesis at negative 19/7 or do I have a bracket there? Sammy? Parenthesis, because I have an open dot. So I have a parenthesis here and a parenthesis here. Okay, second one, go ahead and finish solving it. If you haven't already. Elise, what do you have for a solution?
X is greater than or equal to negative 30/4.
Okay, we have to divide through by negative 4. Negative 4. We have to remember, turn the sign around. Negative 30/4, we can take 2 out of top and bottom, which is what? Negative 15/2, so we have negative 15/2 there. So if we take a look at our solution, once again, you can put in your calculator. 15 divided by 2, negative 15 divided by 2 gives us negative 7.5. So we're between negative 8, negative 7, negative 6. You don't have to get a full entire number line there. Just so you have your central values there. Negative 7/2. We have to be greater than or equal to negative 7/2. Do we have an open or a closed dot there, Zach?
Open.
Open dot. And which direction are we going?
Negative.
Greater than. Positive, so we're going towards positive infinity. Okay, this arrow will tell us which direction to go. So now we go to our interval notation. X is a member of. We have negative 15/2. If you put it in decimals, that's fine. You can leave it as fractions. Going towards positive infinity. Parenthesis or bracket at negative 7/2, Kendall. Bracket here because, oh, that should be a solid dot, my bad. We have a bracket there. And a parenthesis at positive infinity still. Okay, we can throw fractions into this. We can throw fractions into this. Okay, what I'm going to do is I'm going to skip to the back side here and get through one of these in the back. Because I want to combine these together. We have 2x minus 7 is greater than the value 3, and also x minus 2 is less than the value 8. Solve both the inequalities. Make sure you keep the word and in there. Keep the word and in there. Solve both the inequalities. Keep the word and in. Okay, graph both those inequalities. Graph both those inequalities on one number line. And you have the word and in there, so you want the values that are common in both. So graphing the first one, we should have an open dot on 5 going to the right. Graphing the second one, open dot on 10 going to the left. We have the word and in there, so we are looking at the intersection, common in both. So the values that are common in both are from 5 to 10. Then we write this in interval notation. Alright, homework, you have a worksheet here, solutions on the back. We'll work on this a little bit more tomorrow. Have a good day, everybody.